If everyone could take a seat, we're going to start. And to begin the competition, I'd like to invite President Satish Tripathi to say a few words.
Thank you, Graham, and good afternoon, everyone. I'm really delighted to welcome you to the inaugural 3-minute thesis competition hosted by our graduate school and the Blackstone Launchpad here at UB. 3 minutes thesis competition must be really tough. Not for the judges, but for our students. Many of us have gone through a thesis, doctoral thesis of some kind. Some of us almost 40 years ago, some of us more recently. And I don't think many of us actually ever thought about giving the whole thing in 3 minutes. It could either be 10 seconds, this is what I'm working on, or if you want more, it would take you 15 minutes, 20 minutes to listen to. So this must be really tough, but I'm told that you already have gone through one level of competition, and this is now the final competition, and you are under strict time limits. So that's again is tough. I was under a strict time limit, but already have exceeded my time here. So you can see it's not easy to be on a strict time limit. I also want to welcome and thank our panel of judges from the community for their willingness to participate in today's competition. Thank you so much for being here. It is indeed an impressive achievement to reach this point in what has been rigorous competition. So I also want to congratulate our finalists and as they talk about their doctoral work. UB is a research university and actually produces a fair share of doctoral degrees every year. Approximately 1 in 10 doctoral degrees confirmed in New York State come from UB. So really it's a major contribution to the state, and our alumni leaders are all over the span. They work in business and industry. They are in the sciences, they are in academia, they are in arts and culture, and they create their own industry, many of the PhDs, and as well as do all kinds of work actually. It's not just we produce PhDs to clone ourselves to teach somewhere else. They work in many different fields, and they're making contributions. So I'm very eager to see how our doctoral candidates will bring their innovation ideas to the fore of our betterment of our world, and I'm looking forward to listening to it and learning something about their research. So thank you again, and congratulations.
Thank you, President Tripathi. I'm Graham Himmel, Vice Provost for Graduate Education and Dean of the Graduate School, and I want to welcome everybody to the 3-minute thesis competition. The competition is a campus-wide competition that asks advanced doctoral students to present their research to a panel of non-specialists in just 3 minutes. Students who go over 3 minutes are disqualified from the competition, which sounds very harsh, and I'm sorry to begin with a harsh note. It's been really gratifying to see the strong positive response to the event from graduate students and faculty from across the campus. The 3-minute thesis competition is co-sponsored by the Graduate School and Blackstone Launchpad, and I just want to say a lot of people put a lot of work into making this event possible, but I really want to single out very briefly 4 people without whom this never would have happened. Hadar Borden and Rachel Stern from Blackstone Launchpad, and Sandy Flash and Sue Adenolfi from the Graduate School. They've been working on this event for about a year and really deserve a special round of applause. So I'm just going to say just very briefly a few words about the competition and the events that led up to today. The 3-minute thesis is an international competition. It began in 2008 at the University of Queensland. And now the competition is being held at over 350 universities across more than 59 countries. The competition has two primary goals. The first is to share, recognize, and celebrate the excellent research undertaken by doctoral students. The second goal is to encourage graduate students to sharpen the ability to communicate their research both concisely and effectively. At UB, we understand the importance of advanced research, which is really central to our mission. However, communicating that importance can be more of a challenge. Doctoral students spend their days in libraries and laboratories talking with other academics. And when you're in that world, it can be difficult to explain the value of your research. I think about going home after I've been working on my dissertation, going home for Thanksgiving and trying to explain to my parents or my cousins what I've been doing for the last couple of years and getting kind of blank looks and just kind of stopping after that. However, that said, if your research is going to have an impact on the broader world, then it has to be communicated, and it has to be communicated effectively. The 3-minute thesis competition aims to help graduate students do exactly that. So UB's 3-minute thesis competition began actually this past fall with a series of workshops, and the workshops were open to any graduate student who was interested in participating, any graduate student at UB. The workshops focused on the skill of communicating research. Graduate students who are interested in participating in the competition were then able to nominate themselves by submitting a 90-second YouTube video describing their dissertation research and its importance to a non-specialist audience. Today's finalists were selected from that group. And I would just say that the committee that made the selection was charged with choosing 12 finalists, but they refused and chose 15 because of the high quality of the work that was submitted. In preparation, after being selected, each finalist received individual coaching from a Blackstone Launchpad venture coach and participated in a training session led by Dr. Robert Knopf from the Department of Theater and Dance. So everyone here is very well prepared. Over 120 graduate students participated in the initial workshops. 30 students entered the first phase of competition, and as I just said, we now have 15 finalists from doctoral programs across the campus representing all fields of study, broadly speaking, the sciences, engineering, medicine, social sciences, arts, and humanities. Since this is a competition, there are, of course, prizes. The first place winner of the competition will be awarded a prize of $1,000. The second place winner will be awarded a prize of $750. $500 for third place. There also is going to be a People's Choice Award of $250, which goes to the best presentation as selected by the audience here today. Our hope is that the award winners will use these funds to advance their research, maybe attend a conference, or go to an archive, or buy something for your lab, but it's also okay if you include a little bit of celebration in that as well. I know you're eager for the competition to begin, so I'd like now to introduce Scott Weber, Vice President for Student Life, who will introduce the judges and the participants in today's competition.
Good afternoon, everyone. It is really a pleasure to serve as the MC for the 3-minute thesis competition, especially given that this is our first one. It should be an incredible event. The PhD students presenting their research today that are all sitting here eagerly waiting their turn will be judged on their communication style in 2 different ways. First, was the research communicated in a language appropriate for the non-specialist audience? And second, was the one static slide that will be here allowed during each presentation clear and helpful in enhancing the presentation? In addition, the presentations will be judged on comprehension. Did they make the audience understand the research? And finally, presenters will be judged on how engaging they were. Did they leave you wanting for more? I'm sure they will. We are honored today, as President Tripathi said, to have an esteemed panel of judges. I'm looking down on them now, and they are very ready for this to start, whose evaluations will determine our first, second, and third, as Vice Provost Hamill already described. Our panel of judges is made up of community leaders with from a range of industries, from the arts and journalism to medicine and engineering. Our judges are experienced professionals who have mastered the skill of communicating their work to broad audiences, and therefore recognize the development of this critical skill in graduate students and potentially the global impact of global research. So let me ask you to help us give a warm welcome to our judges. And let's start with Maritza Baez, Family Medicine Physician, Lifetime Health Medical Group. Elizabeth Licata, Editor-in-Chief, Buffalo Spree Magazine. Michael Murphy, President, Shays Performing Arts Center. Samuel Severino, President and CEO, Severino Companies. And Jim Werfritz, President, Erie Niagara Consulting. Now, ladies and gentlemen, as Vice Provost Hamill also said, you get a chance to be a judge, and this will be the audience's choice, or called the People's Choice Awards, and your votes will determine that. And we'll have information for you later in the program. It's also in your program at the end, if I remember correctly. But as you're thinking about it, just keep thinking about each of those presentations. The other one thing I wanted to do before I forget, and I'm sure you haven't forgotten, is to turn your phones off. Because when you have 3 minutes, something that could be incredibly distracting is your phone. And I would even ask you maybe to turn it off if you can, rather than just mute it. That's your call. So now on to the competition. Our finalists today represent our finest at UB. I'm going to introduce each finalist to you. As I'm doing so, they will come down and up on stage and prepare to present. I will finish my introduction with the words ready, set, pitch, and I had to make a flyer because I want to say ready, set, go. So I've got it here now, and I'm going to try not to make any mistakes. But if I say ready, set, go, I'm not going to stop you. You just go. And the finalists may then take a moment to sort of collect their thoughts and center themselves, and they've been all told this information. And then they can start. And when they start, you'll see the timer here click, and the slide will appear. And I know you're going to be very enthusiastic for them and encouraging, but again, they are under strict time limits, and so I know that you will be very respectful and no cheering from the audience during the presentation, right? So, I think we should get started. What do you think? Okay. So, starting us off will be Phil Schneider. And Phil's going to talk about TESS Phantom Fingers for higher biometric security. His faculty advisor is Dr. Quang Oh in the Department of Electrical Engineering. A few fun facts about Phil is he has a cotton candy machine in his lab, which he says he only uses for research, which I'm very happy to hear. He's a level 32 in Pokemon hashtag Team Mystic, and he is a Western New York Prosperity Fellow. So, ready, set, pitch.
Biometrics are the statistical analysis of a human behavioral or physical characteristic. This could be anything from an eye scan, to the way you talk, to a fingerprint, or behavioral, how you walk, or do you have an accent. We use biometrics in the world all around us today. Whether you're traveling across the country and you have a passport, that has your biometric. Maybe you're entering in your cell phone and using your fingerprint. That is also a biometric. What if I told you, though, that your biometric may not be that safe? What if I told you that if you were to give me your cell phone, I could lift a fingerprint from your screen, mold a finger around that phone, and get right back into your cell phone? I'd have access to your emails, your contacts, your text messages, Apple Pay, Google Pay, maybe even a bank account. This happens. This is easy to do. Hackers do it, terrorists do it, and PhD electrical engineers can do it. This is a problem that industry has been trying to solve, and it's costing them millions of dollars. And it's a problem that my research is trying to solve. I create what are called TESS Phantom Fingers, and they're essentially replicas of human fingers that recreate the physiological structures inside. My hope with my research is to measure subdermally, or within the finger, to use that as a biometric. So inside the finger, we have things like flowing blood. We have things like arteries and veins. I work with companies' fingerprint sensors to calibrate their system to image subdermally. I give them my test phantom finger, and they image it, and they recognize whether they're doing well from a system performance or poorly. My test phantom finger has to be physiologically accurate, right? So I have arteries, veins, fat, muscle, skin. I have fingerprints. I put bone in there, blood that flows through. It has a heart rate to it. It also has a capillary network. And when I say capillary network, I want you to think about a very small fluidic network at the tip of your finger. How small? Roughly 1/100th of the size of a human hair, just enough for a blood cell to flow through. How do we recreate that? Cotton candy. Turns out the sugar strands of cotton candy, the fibers, are the same size as a capillary network. So I'm utilizing cotton candy in my research to recreate that capillary network to create a really realistic test phantom for these companies to test on. My hope for this research? To create a more secure biometric imaging subdermally to protect both your data as well as my data. And with that, thank you.
I just can't resist. I think, Phil, when you ever say I'm going to give him the finger, it's going to mean a quite different thing now. I just couldn't resist. Our next presenter is Lucy Kafakova, whose title of her dissertation is Figuring Out African Trypanosomes, One Protein at a Time. Her faculty advisor is Laurie Reed in the Department of Microbiology and Immunology. And some of her things that she'd like us to know is she owns a sugar glider. And quite frankly, I had no idea what a sugar glider was until I looked it up, and I'm not going to tell you unless you may already know. She loves magic, dragons, and heroes. So, ready, set, pitch.
In a world where everybody asks, where is the profit? Basic science works with a slightly different equation. You put the money in, and what comes out is knowledge. Basic science is driven by human curiosity, and I am very curious about molecular biology of African trypanosomes. Trypanosomes are single-celled parasites that live in human blood and cause the sleeping sickness. Don't worry, you do not have it. Unless you went to Africa, got bitten by a really big ugly fly, and now you're often feeling like you have a bad flu. In that case, you should get yourself checked. The disease is deadly and not treatable when caught too late. I know molecular biology can sound intimidating, so let's make it more fun. Let's imagine the trypanosome as a Rube Goldberg machine. The receptor on the surface picks up an input, sends a signal into the cell. The signal then travels through a protein cascade until ultimately causing a certain outcome that will be helpful for the trypanosome to deal with whatever the input meant. Except it is not quite this simple. Trypanosomes contain over 10,000 unique proteins that participate in thousands of very intertwined pathways like this one. My task is to find out as much as I can about a protein that modifies the shape and therefore function of hundreds of other proteins. So how do we do that? Well, my favorite way to start is to create a trypanosome that cannot make said protein, and then look for what breaks. Did it stop moving? Is the metabolism broken? Can it divide? Then we can also lyse the cell, causing the whole machinery to spill out, isolate our protein of interest, and look for what sticks to it. Once we think we know what's going on, we can make the proteins, put them in a test tube, and try to replicate simple events that take place in the cell. By these and other methods, I have discovered that my protein of interest, actually, in order to do what it's supposed to, has to be in a complex with very similar but slightly broken protein. This was very surprising because in humans and other organisms, this class of proteins tends to work as a unit of two identical units. So I'm very curious about how this new novel arrangement is going to prove advantages to the trypanosomes or what's going to happen next. Anyway, why am I doing this? Is it really worth spending several years of my life to find the function of a single protein in an odd parasite? I think so. We are uncovering the secrets of life one puzzle piece at a time, and often the pieces that go together come from very unexpected sources. We never know what's going to prove very crucial in the end. And Therefore, we need to keep trying to find everything we can. Thank you.
Thank you, Lucy. Our next presentation is from Holly Kiley, whose title is Gesturing to Make a Point. Who is that gesture for? Her advisor is Jürgen Bonemeyer and from the Department of Linguistics. And Holly's got some pretty interesting things going on. She has been all over the world. She's a soccer certified referee, loves snow enthusiast, and she's an expert in pearls. Ready, set, pitch.
We wave our hands around when we talk. It's okay, everyone does it, it's fine. We're gesturing. We use gesture to help us describe the size or shape of things, like this fish I caught that was this big, you'd never believe. We use gesture to give people directions on how to get places, to explain how things work, like a Rube Goldberg machine. We use gesture when it doesn't seem to mean anything at all. So what is the point of doing it? You can understand me without seeing my gestures, and I can talk to you without gesturing. But that's not what people do. We use gesture. Who are we gesturing for? There are two kinds of answers to this. I could be gesturing for myself, the speaker. I could be gesturing to help me remember what I'm going to say or think of the word that I want to use. I could be gesturing for you, the audience. I could be trying to direct your attention to me or something else. Or I could be gesturing to illustrate something for you so that you can come up with a mental image of it. I want to know which one we're doing. I've had people watch events and then describe them, and I watch them describe things to other people. I found that we have a negative correlation between the rate of gesture and the length of a description. So that means that I get really short descriptions with a high rate of gesture, a lot of gestures. I'll get something like the following. There's a girl, and she has this kind of like mallet thing and a long stick in front of her, and she takes the mallet and she smashes the stick and it goes everywhere. That's like 25 words and maybe 8 gestures. That's a lot. I also get really long descriptions with very few gestures, so I'll get something like this. There's a girl, and there's a table, and there's a stick on the table, and the table's maybe trapezoidal. I think it's kind of a light brown color, but it looks like it might have a tablecloth over it. But anyway, she has a hammer, and she uses the hammer to smash a stick, and it goes all over the place, and some of the pieces land on the table, and some of the pieces land on the floor. Now, that's like 50 words and 1 gesture. It's a little unusual. That's unexpected. It's not what I thought I would get. What does it tell us? Well, it kind of tells us that we are gesturing for the audience. Because if I was gesturing to help myself as a speaker, I would expect that as I say more things, I need more help, and so I gesture more to help myself more so I can say more. That's not what people get. That's not what we're doing. This implies that my gestures are something that I'm doing to try and communicate to you specifically. I want to visually highlight, underline, bold, italicize, or emphasize something that I think that you should think is important. So who am I gesturing for? Well, at least when I'm describing events, I'm gesturing for you. Thank you.
Thank you, Holly. Our next presenter is going to be Johan Kuhl, and his title is Et Brute, Detecting Insider Attacks to Databases. His major faculty advisors are Shambhu Upadhyaya and Oliver Kennedy, and they're in the Department of Computer Science and Engineering. And I don't know if he likes to play guitar. He was going to be a scientist at an early age, but when he took a little break, he watched a little Gossip Girl, apparently. So, anyway. Ready, set, pitch.
Friends, Romans, countrymen, lend me your ears, and imagine a world where Julius Caesar had not gotten stabbed by his friend Brutus. In that world, maybe he would have conquered Britain. Maybe William Shakespeare wouldn't have written his play Julius Caesar, and maybe his name would be Marco Shakespeare instead of William. Enough counterfactuals, though. Let's fast forward to our century. I'm sure you have heard the names Bradley Manning and Edward Snowden on the news. Although they were trusted people, they stole critical intelligence documents and released them. Worse came later in 2015. Office of Personnel Management of the US disclosed that someone had acquired personal information of 22 million federal employees, including employees with the highest level of security clearance. Whoever did this, they put the security of the entire nation at risk. They risked your families, they risked your friends, they risked your freedom. Did they get caught by the security measures in place? No. Remember, there are layers and layers of security measures in these systems against hackers. But an employee is already inside these layers and may have access to a lot of information that nobody has. My research focuses on detecting insider attacks to databases, attacks coming from people you trust. I monitor behaviors of users and how they interact with the organization's database. I use the query logs, and these query logs are the records of questions that people ask to the database and the way they ask them. We collected 3 real-world data sets, one from a national bank, one from smartphone applications, and one from student assignments, to understand how people write the queries. We use these queries to create personal profiles. The detection mechanism depends on these personal profiles and uses statistical information, statistical methods to understand what the change is about. You may think that maybe we are overreacting. We should trust our employees. That is correct, completely correct. But better be prepared than sorry, right? If you don't believe me, you may ask my friend Julius Caesar over there. I'm sure he will watch for me. Thank you.
Thank you, Johan. Trying to give the judges just a little time when they're doing their score sheets between these. Our next presenter is going to be Chuan Zhang. And the title of the presentation is An Enzyme to Remember with No Strings Attached. The faculty advisor is James O'Donnell in the Department of Pharmacology and Toxicology. She loves apparently bad jokes and Wikipedia, and we're super excited to have her here as well. So why don't you come up on stage? And ready, set, pitch.
Remember one time when you walked out of a shopping mall, went into the parking lot, and for a second you forgot where you parked your car? Once or twice, that's okay, but when this keeps happening, or even worse, it comes to a point where you couldn't find your way home. And that person is probably going to be diagnosed with memory disorders. As unfortunate as that can be, there are no treatment. Only a few FDA-approved drugs have shown to relieve the symptoms, but none of them slow down or reverse the disease progression. Now, come to think of it, memory disorders may result from a wide range of causes, so it is difficult to pin down to a specific drug target based on that. Alternatively, it's not a bad idea to think about the memory process itself, and that's what I'm interested in. Decades ago, a signaling molecule called cyclic AMP was found to be critical to the memory process. And this cyclic AMP, also known as CAMP, is controlled by an enzyme called PDE4. And back then, a drug was found to inhibit PDE4 and improve memory, both in lab animals, which we work with, and humans. Exciting, right? But this drug also produced severe nausea and vomiting. And for years, it seemed impossible to separate the beneficial effect and the side effects. For my dissertation project, I've been working with a biotech company on a new class of PDE4 inhibitor. And specifically, we targeted PDE4D, which is a small group of PDE4. Now, let's take a look at this image here. Think of when you are trying to wash your hands. On the left, the old drug turns the faucet all the way up, gives you a big stream of CAMP. It gets the job done, but you also end up splashing yourself, just like some brain areas are flooded. And on the right, The new inhibitor that targets PDE4D gives you just the right amount of water flow and lets you efficiently wash your hands. You've probably figured out by now, less is more. As I mentioned before, we work with lab animals. How do I know it's the same for humans? Well, for starters, we made a mouse model that expresses human-type PDE4D. And I've shown that this new inhibitor improves memory in this mouse model. And more importantly, without causing any concomitant nausea and vomiting. I've also looked at the actual changes in the proteins and the activity level of the brain that are caused by this drug. And all those information tells us this may indeed be a better functioning brain. My data supported phase 1 trials in humans in which this new inhibitor, first in its class, showed promising results. And this brings hope to not only people with Alzheimer's, but also those with other memory deteriorating conditions, even like aging. Thank you.
Thank you, John. Our next presenter is Antonella Di Giulio, whose title is Fountain of Youth for Brains, a Map of Sounds. Her faculty advisor is Brian Mosley, and she's from the Department of Music. And she was born in Germany, but clearly Italian, and speaks 4 languages. And so we're super great, it's super great to have her here. So, ready, set, pitch.
Would you like to live forever? If you think, probably not. But would you like to be forever young? Maybe yes. We haven't found a fountain of youth for our bodies, but we might have found one for our brain. Our brain is a powerful instrument. It has 90 billion nerve cells and an infinite number of pathways for the brain signals to travel through. The bad thing about the brain is that it will start to shrink at a certain point in our life. But here's the good news. We have a powerful anti-aging product, which is music. Research has shown that just listening to music can improve our cognitive abilities. However, many researchers, when dealing with music, they feel lost because they lack knowledge in music theory. They cannot really identify which combination of sounds is influencing the brain and why. So what if these researchers could use a kind of GPS to navigate complex music analysis? They will be able to translate sound information that music theorists will give them into data for their research. That would be awesome, right? So let's compare the different musical genre to places on a map. And then let's compare a piece of music to a route from a starting point to a destination. The essential points of orientation on this map are a particular combination of sounds, main characteristics of this route, or special effects. In a 3-step process, my sketching method is translating traditional music analysis into an easy-to-read but detailed 3D map of any piece of music. The first step will look at an overview of the piece, and will identify the main point of interest. The second step will aim to identify the details of the point of interest and then discover similarities and differences. The third step will summarize the information into one single image. Through this system, researchers will be able to use this data as a GPS. They will be able to find the fountain of youth. And then they will help keep our brains young. So, and keep in mind that music is a fountain of youth. Thank you.
Thank you, Antonella. Our next presenter is Muhammad Utif Ufazal, and his title is Accelerated Discovery of High Performance Materials. His major advisor is Johannes Hockman in the Department of Chemical and Biological Engineering. He loves tennis, puns, and not to be outdone, also speaks 4 languages. So, ready, set, pitch.
Let's consider a scenario. Let's take 2 cups, one made out of a plastic material and another made out of a glass material, and drop them both on a hard floor. What happens? Of course, the glass material breaks, and the plastic material remains intact. You're probably imagining, what if your phone is made up of complete plastic materials? You will never have to see something like that. Well, the problem is the current existing plastic materials do not have sufficient properties to be used in such devices. In my research, I'm designing new plastic materials so that our phones never break. One interesting thing about plastics is that the molecules that can make plastic materials is basically infinite. That means there exists a combination of atoms that can make a plastic material with a targeted property. However, it's a challenge to find the right combination of atoms in this huge molecular space. Therefore, in my research, I'm designing millions of potential molecules and then computationally evaluating them using an infrastructure which is built using complex calculations, and all the calculations are performed on a supercomputer. Now we have evaluated millions of molecules, and we have large amounts of data. We can look at the data and understand what's going on with the molecules and how the molecules are behaving. But a human brain can only look at few molecules and maybe design a new material based on intuition, which is what scientists have been doing in the past. But finding patterns in millions of data is quite not feasible. Let's consider a classic example of needle in a haystack. It's nearly impossible to find the needle with our bare hands, but we can accelerate the process of finding the needle by creating robots and teaching them to find the needle for us. In my research, I'm using a very similar idea. I'm creating an automated framework that can basically find the atoms of combination of atoms so that we can design the material with the targeted property. I'm doing this by basically teaching the computers to learn from the available data, which is called machine learning. And the particular algorithm that I use is called neural networks. This is because it works very similar to how our brains are operating. Let me tell you that this technique is being used by tech giants such as Google, Microsoft, and Facebook to do tasks such as facial recognition and voice recognition. In my PhD thesis, I'm extending these techniques so that I can discover next generation of high-performance materials so that our phones don't break. And because I'm using plastic materials, our phone can be flexible, lightweight, and also cost-effective. Thank you.
Thank you, Mohammed. Our next presenter is Kristen Mackey, and her title is a Story Worth 1,000 Numbers? Her major advisor is Thomas Feely in the Department of Communications. She's a map carrier, apparently, a hockey player, and has a memorized chocolate chip recipe if you need it at the end of the presentation. So. Ready, set, pitch.
In 1985, Lisa had to have a blood transfusion. She was worried because this was before transfusions were routinely screened for safety, and HIV was on everybody's mind. But she felt okay afterward, and she's been pretty healthy since then, aside from feeling tired at times. But the last time she was at her doctor's, Lisa got tested for hepatitis C, which is a blood-borne virus that affects the liver. As it turns out, Lisa has hepatitis C and significant liver damage because she most likely contracted the virus from that transfusion more than 30 years ago. I'm telling you this because my dissertation research compares the effectiveness of narratives or stories that are similar to Lisa's with statistical information, which is what's typically seen in health-related messages. Prior research suggests that narratives may be one effective way of conveying this type of information. One reason is because narratives tend to be more easily comparative with our own lives. But as you can see, a lot of health messages still rely on numbers to make an impact. I'll give you another example related to this. So adults who were born between 1945 and 1965 are 5 times more likely to have hepatitis C than other adults. Also, those who were born between those years, as you can see, make up 75% of the people who have hepatitis C. And the CDC estimates that of all of the people who have this virus, up to 75% of them don't know because they haven't been tested. As you can see, these numbers can help show you what a big problem something is. But on the other hand, they can be hard to make sense of, especially if the same number repeats for different things, like 75%. It can also be hard for people to relate to those. So to account for this, my research includes a narrative, like Lisa's story, along with statistical information, like I told you. But it also includes a third format that pairs both of these together. So for instance, after hearing that people in her age group are 5 times more likely to have hepatitis C than other adults, Lisa decided to get tested for this blood-borne virus. I'll let you fill in the rest, but as you can see, this kind of lets you have the best of both worlds. And at the end of the day, this might be the most effective way to convey this type of information. So the implications from this research are really exciting because they could help influence future message design and in turn help people like Lisa to change their story. Thank you.
Thank you, Kristen. Our next presenter is Nadav Weinstock. His title is Understanding Krabbe Disease. His faculty advisor is M. Laura Feltry in the Department of Medicine and Biomedical Sciences. He, I don't know the circumstances, but apparently broke both his arms when he was a child at the same time.
Yeah.
Loves squash, the sport, not the vegetable, which I think is awesome, and hopes to travel to outer space sometime in the future. So, ready, set, pitch.
A parent's love for their child is powerful. That love is limitless and unconditional. And if a child gets sick, a parent's love perseveres. It's that love that encourages me to become a pediatrician and to join in the worldwide effort to cure childhood disease. I study Krabbe disease, a devastating neurological disease that affects babies. Some of you may have heard of Krabbe disease from local Hall of Fame quarterback Jim Kelly and his son Hunter. When Hunter was just 3 months old, he was diagnosed with Krabbe, and doctors told the Kelly family there was nothing they could do. Hunter fought bravely, but like all children with Krabbe, ultimately passed from his disease. Today, more than 20 years after Hunter's diagnosis, not much has changed in the field. There's still no cure for children with Krabbe, and there exists a fundamental gap of knowledge regarding what causes the disease and why our treatments aren't working. To help you understand Krabbe, I want you to imagine your own life if the garbage man never showed up. Garbage would accumulate, first in the kitchen, then in the living room, then the whole neighborhood. Something very similar happens in Krabbe. Patients are missing an enzyme, and without that enzyme, cellular waste accumulates, causing disease. The problem is we don't know where that toxic waste is coming from, and if we don't know where the problem starts, how can we fix it? My research project focuses on answering that question. By using a series of cutting-edge genetic tools that my mentor and I helped create, we're now able to pinpoint precisely where that toxic waste is coming from. Shortly after starting our experiments, we made a meaningful discovery. We found that one of the cells that contribute to this disease is a cell type known as the Schwann cell. Interestingly, we found that Schwann cells can cause disease even when the surrounding cells are healthy. This last point is important. It contradicts what we thought we knew about the disease. For years, we thought that any sick cell could be helped by a healthy donor cell. That was the basis of our treatment option. Children would receive bone marrow transplants from healthy donors. Our data not only suggests that Schwann cells may contribute to the disease, but also may explain why our therapies aren't curative. And with this information, we can design better therapies that target the underlying problem. Every year I meet dozens of families with children affected by Krabbe. Their lives were turned upside down overnight. One moment they had a healthy child with their whole life ahead of them, then the diagnosis came and their lives were changed forever. But the story doesn't have to end here. With our research, we're closer to finding a cure than ever before. Thank you.
Thank you, Nadav. Our next presenter is Saida Fatakari, and her title is Less Pain, Lower Cost by Health Information Sharing. Her faculty advisor is Professor Ram Ramesh in the Department of Management, Science, and Systems. She's fulfilled a childhood dream by visiting Niagara Falls and loves Wegmans and art museums. I love the juxtaposition. Ready, set, pitch.
Hello, everybody. Imagine that you don't feel well today. You go to see a doctor, and the doctor simply orders a blood test to decide about your medical condition. You may say, wait a moment, I took that test recently. I don't want to take it again. But you know, if the results of your previous test is not available, you have to take it again. Can you guess how many of the medical services are unnecessary and just because of the missing information? It's a lot. In the United States, it's almost 30% of the healthcare annual cost. These repetitions, of course, are risky and costly for the patient and costly for the healthcare system. To overcome this issue, a managerial program called Health Information Exchanges has been implemented in the US healthcare system since 2008. How does this program work? In this program, all patients' medical information from any point of care, such as insurance information, lab test results, physician records, hospital records, and prescription information are securely saved as electronic medical records. When a patient is visiting a doctor, given the patient consent, the doctor can access to the patient's medical information whenever it's needed. What are then the benefits of this program? Here is where my research begins. This information sharing program helps doctors to make more informed decisions about the patient condition, diagnose better, and perform less repetition of medical procedures for their patient. In my research, by analyzing the data on more than 3,000 physicians, I found that physicians who use this program perform less duplication of medical procedures when patients visit their office. Thus, we found that this information sharing program leads to delivering more efficient healthcare services by medical providers, and most importantly, this program leads to less pain, less risk, and lower cost for the patient. Thank you very much.
Thank you, Saida. Our next presenter is Peter Bloomingdale. Peter's title is Networks, Nerves, and Cures. His major advisor is Donald Major in the Department of Pharmaceutical Sciences. Apparently he cooks great Indian food and is a challenged shoe shopper and has not been in the Harry Potter. I don't know where that's going, but we're going to let him play that out. So, ready, set, pitch.
When I began my PhD, I always envisioned curing a disease. Initially, I wanted to cure cancer. High hopes, I know. But after reading about cancer and the different treatment options that are available, I became interested in the adverse effects of chemotherapy. My research focuses on one of these, chemotherapy-induced peripheral neuropathy. Chemotherapy is the use of toxic chemicals to kill cancer. However, this is essentially a poison. When this poison enters our body, it distributes everywhere and damages everything in its path. When it distributes to our peripheral nervous system, it causes nerve damage known as peripheral neuropathy. Patients that develop peripheral neuropathy will feel a numbness and tingling sensation in their hands, feet that travels across their body. Now, the problem is that this will turn into an extreme pain. The goal of my research is to prevent this pain, to prevent peripheral neuropathy from occurring. And to do so, I built a biological network of our nerve cells. To give you an analogy, I'll use a network that we're all familiar with, Facebook, the largest social network. Here, dots represent people. Connections between these dots are if people are friends. It's very similar in a biological network, except for the dots are genes and proteins inside the cell. And the connections between these dots are if these genes and proteins interact with each other. Now, if we take everyone who's on Facebook and looked at their physical location in the world, what would we see? We would see something that looks exactly like this. It's pretty amazing, right? Upon zooming in, you would notice that people are clustered together in cities. And in network theory, these clusters are termed motifs. Now, motifs are important and very interesting because they relate to function. Now, if you looked at New York City, you'd see people clustered around there that form a motif. Its functions related to the economy. It's the economic powerhouse of the United States. Whereas in biology, genes and proteins cluster together to form these motifs, such as the mitochondria, which relates to energy production, the energy powerhouse of the cell. So for my research, what I've done is I've analyzed the motifs in this network of our nerve cells. I then looked at healthy nerve cells compared to nerve cells that have been damaged by chemotherapy. And interestingly, I identified two motifs that become damaged. One is our mitochondria, and the other involves our immune system. This network-based approach has allowed me to identify a novel drug to prevent nerve damage and pain associated with chemotherapy, potentially curing peripheral neuropathy. I'm currently testing this treatment in mice, and hopefully one day I'll be able to try this in humans. Thank you.
Thank you, Peter. Our next presenter is Danielle Chum. Her title is Switch Cancer Off. Her major advisor is Scott Abrams. The department is microbiology and immunology. She believes that sushi is the essential, I think, element for graduate persistence, as are pound cakes and podcast. Double Ps. Ready, set, pitch.
What if you could switch cancer off? In order to do this, you would have to employ the greatest army alive, our immune systems. This is because in this army, there are soldier cells called macrophages that can be trained to wage war on parasites or to keep peace. This ability of macrophages to switch between these two sides is possible due to the manipulation of internal switches called transcription factors. During illness, you want macrophages to wage war, not keep peace. Yet in cancer, this is not so. Why does this happen? We think that even though the immune system sends war-waging macrophages to the cancer, through some seduction routine, their switches get jimmied, resulting in the cancer spreading, which is what kills most patients. So how do we interrupt this seduction routine? Go for the war-waging switches, of course. I study one of such war-waging switches called interferon regulatory factor 8, or ERF8. ERF8 is critical in the arsenal for war-waging macrophages. So we asked the question, what if we switched ERF8 on and kept it on? And I'm talking about very, very high levels on, flaming bright. To do this, we created a mouse where ERF8 was switched on in the macrophages all the time versus a mouse where ERF8 was switched off completely in the macrophages. And then we asked, does the cancer spread more or does it spread less? As you can see from here, when the ERF8 switch is off, the cancer spreads from the breast to the lungs significantly, resulting in this sad mouse that eventually dies. However, when ERF8 is turned on and kept on to very, very high levels, the cancer spreads less from the breast to the lungs, resulting in this happy mouse and this mouse surviving. What does this mean for the patient? It gives us a target. It gives us something, a starting point where we can start to intervene with therapy that will eliminate overtreatment of patients. It gives us something tangible that we can finally use to switch cancer off. Thank you.
Thank you, Danielle. Our next presenter is Shannon Tai. Her title is Where Do Trees Die? Advisor is Scott Mackay in the Department of Geography. Loves chicken wings, and to balance that, loves to hike and bike along the Niagara River. Ready, set, pitch.
Our forests are dying. This recent warming and reduced rainfall are killing trees. Without sufficient water, trees could not function properly and are more likely to be affected by disease, insects, and eventually die. But questions remain about where do they die and why. Do trees die randomly by chance? Or if there's a reason behind? That is the central question of my dissertation. Now let's take a look at this bird view photo taken by flying a drone over my study area in southern Wyoming. We can see that some trees fell apart after they died and create this open ground. And some trees are close to death with their canopy turning gray or brown. And the other trees remain green and happy. Notice the spots where the cluster with dead trees. That pattern suggests that trees do not die randomly. There is a reason behind. What could be the underlying factors? I find a number of things: soil types, plant differences, and microtopography. That is the subtle fluctuation of land surface. Imagine that when it rains, some local depressions tend to collect water and remain wet for a longer time, while others become dry pretty fast. Some soils can hold more water, and some plants may grow deep root, allowing them to access additional water. In order to understand how those factors combine to influence the amount of water that a tree can get, we need to know the movement of water laterally across the landscape and vertically from soil to plant. How do I deal with this complexity? As a geographer, I was trained to integrate multiple disciplines. By relying on knowledge from geology, soil physics, and plant biology, I built a computer model that can capture those factors and predict the water uptake by every individual tree across the landscape. This model will be combined with sophisticated observations of soils and plants to help us understand the pattern of mortality that we see here. Ultimately, my research will predict locations with vulnerable trees in a changing environment and help us better protect our forest, which is so critical for all the lives on Earth. Thank you.
Thank you, Shannon. Our next presenter is Human Ansari, whose title is Pacemaker Energy Harvester. His advisor is Dr. Amin Karami in the Department of Mechanical and Aerospace Engineering. He loves turtles, or maybe he only likes them, I don't know. He used to play table tennis professionally. I've got to find out more about that. And he's cracked his head 3 times. So, with that all said, ready, set, pitch.
Hi, everyone. Today I'm going to talk about energy harvesting for pacemakers. But before I start, I'm going to ask you 2 questions. So by raise of hand, how many of you know what a pacemaker is or have some idea about pacemakers? Great. And the second question is, how many of you have pacemakers or know somebody who uses pacemaker in their body? Cool. Okay, so for those of you who might not be familiar with the subject, pacemaker is a device, implantable biomedical device, that is implanted inside the body of the patients who have heart problems such as arrhythmia. It helps them to have a better life. About 3 million people worldwide, they use pacemakers, and 600,000 surgeries are done each year for placing new pacemaker inside the body of the patients. From this number, about 1/3, which is 200,000 surgeries, is for replacing the old pacemakers. And now you might wonder why such a sophisticated device needs replacing. And the answer is with their battery. Like any other devices that depend on battery, after a while the battery dies out and the patient needs to do a surgery. This time varies from 7 to 12 years depending on the activity of the patient and the age of the patient. The surgery, the new surgery, is costly and also has its own risk. The cost of the surgery is between $20,000 to $90,000, and also the risks are associated with the surgery includes heart infection, which is a serious problem for old people. So now the solution that I've been looking into for the last 3 years for my PhD is an energy harvester. Our energy harvester is going to replace the battery inside the pacemaker. It's going to get the vibration from the heart and convert it to the electricity needed for the pacemaker. So by doing so, the patient doesn't need to do a new surgery since our device is self-charging. Our device is small and also is MRI compatible, which means that the patient can do MRI while has this device inside the body. During my PhD time, I published several journal papers and conference papers, and our team has 2 patents on this subject. Last summer, with the collaboration of University of Michigan, we did the first animal test on the energy harvester while we attached the energy harvester to the heart of a sheep. And hopefully in the future, near future, we're going to have our energy harvester inside the commercial pacemakers in the market. Thank you guys for listening.
Thank you, Huma. Our next presenter, and our last presenter, is Van Anvika Nguyen. Her title is Clipping Wires Inside a Biological Bomb, Targeting Cancer's Weak Links. Her advisor is Donald Major from the Department of Pharmaceutical Sciences. She's a relentless sampler of ethnic food. She is obviously born in Russia, I think, and enjoys computer programming, psychology, and fashion. Ready, set, pitch.
Imagine yourself being strapped to a time bomb, like the one you see in the picture on the left. You know that you have to cut certain wires to stop this bomb from exploding, and you know that if you do that in the wrong order or touch wrong wires, the clock might start ticking a little faster. What are you going to do? Fortunately, I don't deal with explosives, but my research pertains to something equally complex and scary, a biological bomb called cancer. I wish I could find a cure for cancer, but over the time, scientists realized that one solution-fits-all approach really does not exist for cancer. Just like you don't expect to find one perfect way to defuse every single bomb out there, you shouldn't expect to find a magic therapy that will work for every cancer type or even subtype. So, does it mean that we should all just give up? Absolutely not. It means that every cancer requires a tailored approach. But I believe that the more you know about your enemy, the more likely you are to win the war. What I'm saying is that if you want to find the best treatment strategy for your cancer of interest, you want to start by collecting all available information about the processes or wires that drive the functioning of your cancer cell. My work is focused on non-Hodgkin lymphoma, which is a blood cancer. I am interested in knowing why patients with different subtypes of the disease do not respond in the same manner if given the same treatment. My analysis point out that the differences we observe could be partly explained by the ways these subtypes are wired, which changes altogether how we should treat them. But first, I need to know the structure of these biological bombs and what they're made of. So, I put together a puzzle, or what we call a network, that paints a comprehensive picture of what's happening inside lymphoma cell, very much like the diagram on the right. This picture would be slightly different depending on which genetic alterations were introduced in each subtype that cause the normal cell turn to cancer cell. Therefore, the most appropriate drug treatments for each subtype will also be different, and we can determine that by applying techniques that are based on mathematics and biology. However, identifying most promising wires to clip is no longer enough. Cancer therapy has become increasingly complicated due to an understanding that more often than not, patients require a multi-drug regimen to overcome this devastating disease. We need to know which combinations of wires will merely slow down the clock and which one can actually terminate the bomb. This is where mathematical modeling comes into place. It allows us to predict what, when, and just how much to give to patients before we even go into clinical trials. Doing so can significantly cut down the time that it takes to develop successful therapies that can save lives of thousands of patients. So we've come a long way in understanding and battling cancer, and we still have a lot of work ahead of us. But I'm confident that we will get there, one wire at a time. Thank you.
Thank you so much. Ladies and gentlemen, we have just enjoyed 15 incredible presentations, and I'm sure you enjoyed them as much as I did. Let's give another round of applause to all of our presenters. Our judges are working on their last evaluation, and when they're done that, we're going to allow them to step out of the room, and you can do that whenever you're ready so they can begin their deliberations. And I think they're going to have a tough job. I would point out that we've retained Price Waterhouse to help with the sorry, it just popped up, you know. But while they're doing their fine work and tough work, remember what we said at the beginning of this presentation and event, that we said that you in the audience were going to have a chance to be a judge as well. So I think what we're going to do is we're giving you time to get your devices out, turn them on. Now it's appropriate. And pull them up. And pretty soon I'm going to give you a signal when you have about 3 minutes. We'll open the voting for about 3 minutes. The web address is, as you've seen up there. I'm not going to try to spell it out for you. And are everybody ready to vote so you have time? I don't want to start too soon. I don't hear any objections. So I think we have to say, ready, set, vote. The voting is closed. Ladies and gentlemen, just a few thoughts that I was collecting as we went along. We had 5 schools or colleges represented today from the university, which is terrific. We had 10 countries represented and 4 continents represented in our pitch participants today, which really does speak to the global nature of the University of Buffalo. Well, the judges need a little bit more time than you did for your voting. So we have a brief interlude to provide a little entertainment before the award presentations, and please do stay, I'm sure you will. But for our entertainment, while the panel deliberates, it's my pleasure to introduce UB's own Buffalo Chips. So please give them a warm welcome as they come down to the stage.
That's on. That's on. You don't think you do? We'll see.
Microphone.
Yeah, no, yeah, drop. Here, I'll sit down. Okay.
Well, there's a light coming from the window and it shines down on the street. There's some guys standing on the corner singing that good old harmony. And as I rise up from the shadows and my voice carries down the street, I said I'm alive and I'm proud to be just singing that good old harmony. I'm singing out soul to soul, soul to soul, and brother to brother, brother to brother, acapella. good to me. I'm singing out soul to soul, and brother to brother, oh, acapella. It sounds good to me.
Well, I just want it understood. The boys brought boogie to my neighborhood. Standing under the light, hey, hey, down there. Oh, it's that good old acapella. It sounds so sweet. Said I'm alive and I'm proud to be just singing that good old harmony. I'm singing out soul to soul, soul to soul, brother to brother, acapella. It sounds good to me. And I'm singing out soul to soul, soul to soul, and brother to brother, acapella.
Acapella sounds good to me.
Hello everyone, once again we are the Buffalo Chips. We are UB's only all-male acapella group. We are so thankful to be here today. We hope you guys had a great time, and next up on the solo is Khalil.
When I turn down the lights and I say goodbye to another night, I'm gonna rest my weary head and put my bones away to bed. I'm gonna get on my knees and pray to the Lord to give me just one more day. Oh Lord, hear my plea. That music means so much to me. I'm singing that soul to soul, soul to soul, brother to brother. Acapella sounds good to me. I'm singing that soul, soul, brother to brother, brother. Acapella sounds good to me. Shoo-be-doo-wop, bop, bop, shoo-be-doo-wop, shoo-be-doo-wop, bop, bop, shoo-be-doo-wop, bop, bop, shoo-be-doo-wop, shoo-be-doo-wop, I say, shoo-be-doo-wop, bop, oh yeah, shoo-be-doo-wop, shoo-be-doo-wop, bop, bop, shoo-be-doo-wop, bop, bop, whoa, yeah.
So our next song is going to be New Shoes by Paolo Nutini. Not Nutella, Nutini.
One, two, three, four. Woke up cold one Tuesday. I'm looking tired and feeling quite sick. I felt like there was something missing in my day-to-day life. So I quickly went to the wardrobe. There was some jeans and a t-shirt that seemed clean. Topped it off with a pair of old shoes that were written so around the seams. Now I thought these shoes just don't suit me. 1, 2, 3, 4. Hey, got those new shoes on and suddenly everything's right. I said, hey, got those new shoes on and everyone's smiling. So inviting, shout out money for a long old time. Slowly strolling in the sweet sunshine, and I'm running late. I don't need any excuse, just wearing my brand new shoes. Woke up late one Thursday. I'm seeing stars as I rub on my eyes, and I felt like there were 2 days missing as I focus on the time. And I made my way to the wardrobe. But I stopped with the shock of what I found. Of all of my friends, they were dancing around and round. I thought, hello to new shoes, bye-bye blues. Hey, I don't know new shoes on and suddenly everything's right. I said, hey, I put some new shoes on and everyone's smiling. It's so inviting. Short on money for a long, long time. Slowly strolling in the sweet sunshine, and I'm running late. I don't need any excuse, just wear my brand new shoes. Here we go. Na 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 na, den 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 den, do na 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 na, do do na na na. walking till the break of dawn. Well, hey, I know no new shoes on, and suddenly everything's right. I said, hey, I know no new shoes on, and everyone's smiling. It's so inviting. No, no, shut up, Johnny, no, 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 my brand new suddenly everything's right. I said, hey, I put some new shoes on and everyone's smiling. It's so inviting. Shut up, nutty, slowly strolling into the sunshine. I'm running late, I don't need an excuse, 'cause I'm wearing my brand new shoes.
So next up, we have the song Valentine by Train. This was debuted at our Valentine's Day annual concert. So, yeah, Eric and Khalil will be soloing the song.
Bum 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 my funny Valentine, I don't know what's on your mind. I don't know that you cry sometimes. Baby, it's all in your head. Do you remember what I said when we sat there on your bed? That I'm never gonna tell you lies. I'll always stand by your side. So when we gonna realize I'm never gonna say goodbye.
Okay, so wow, that was a lot of big singing. So next up we have our alumni song. It is called A Crazy Little Thing Called Love. So Colin Mims, take it away. on. There goes my band. She knows how to rock and roll. She gives me hot coffee, but she leaves me in a cocoa sweat. I gotta be cool. Get on my tracks, take back, hitchhike, take a long ride on my motorbike until I'm ready. Crazy little thing going doom 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 doom. There goes my band. She knows how to rock and roll. Crazy. She gives me hot coffee, but she leaves me in a cocoa sweat. Gotta be cool.
He's not cool. He's really not that cool.
Get on my tracks, take a back seat, hitchhike. I take a long ride on my motorbike until I'm ready. Crazy little thing called crazy little thing called love. Do I? So next up, we're gonna bring back up Eric Zimmerman, and we will be singing "Who's Loving You." One, two, 1, 2, 3, 4.
Sit around with my head hanging down, and I wonder who's loving you. But girl, since you went away, don't you know I sit around with my head hanging down, and I wonder who's loving you. The life without love, it's so lonely, baby. And I don't think it's gonna work. All my life, I've been with you only, baby. So come on, baby. So come on and take it. Woo! All I can do since you've been gone is cry. Don't you wear your pretty little head off. Don't you know I sit around with my head hanging down, and I wonder who's loving you.
Okay, thank you again so much for having us.
Come on, big round of applause.
Fantastic, fantastic. Was it tough?
Yes.
Excellent. At this time, it's my great pleasure to welcome Provost Sikorsky to the stage to provide some closing remarks to the awards presentation.
Wow, what an afternoon's entertainment. All right, both listening to our pitches and listening to the music. This is what Research University is all about. It's an afternoon's stimulation as we move forward to advance knowledge and change the world. Here at UB, we really are a research university. We value the scholarship that we put forward, and we change the world with the scholarship that we do. We train the next generation of professionals and leaders through the PhD programs that we offer, and the way we communicate our research is becoming of growing significance, importance to us. That the outside world looks at universities now and they'll say to us quite often that, it's just academic. And when they say it's an academic problem, we're being dismissed, meaning that the work that we do isn't important. But the work we do is vitally important to the directions that the nation is going, that the way New York State is going, where Buffalo is going. The work we do does have impact. And I think one of the reasons why we're dismissed with, it's just academic, is that we haven't spent enough time thinking about the way we communicate our research, why we do it, how we do it, and what the impact it has is. And that's what this 3-minute thesis competition is all about, is to learn how to communicate the research that we do in a way that the general audience can understand it and can appreciate the value of the research that we do. So I thought that the pitches were simply fabulous, and I thought the a cappella singing was grand. So what I'd like to do now is to thank Scott Weber, who was our fabulous MC, thank all of our pitchers over there that took the time to prepare the 3-minute pitches for us and give them to us, and our panel, and who are now we're going to hear the news of who's going to win the 3-minute pitch competition, and I'll turn it over to Graham, who will take us to the end. So thank you all very much. Oh, I'll come. Oh, absolutely. Go ahead, Graham.
I'm very excited to find out who the winners are. Exactly. No envelope mistakes or anything. Okay. Before I announce the winners, I know everybody's eager. I also want to invite everyone to a reception in the atrium immediately after the People's Choice Award is announced. So the third place winner is Human Asari, Pacemaker Energy Harvester. Some of you may not catch the reference, but I feel like Ed McMahon. The second place winner is Danielle Twum, Switch Cancer Off. First place winner, $1,000, is Phil Schneiderer, Test Phantom Fingers for Higher Biometric Security. finally, People's Choice, Saeed Eftekhari, less pain, lower costs by health information sharing. So if the winners could remain on the stage for just a moment, and everyone else, please join me in the reception, in the atrium for the reception. And one more round of applause for the participants and for the judges.